Now that we've learned about integration, we know how to integrate under the curve and the area between two curves, we can use the same ideas to find or calculate volumes, what's known as volumes of revolution. Specifically, we're going to look at two different methods. The first being the disk method and the second being the washer method. So let's jump in right away and look at an example and develop the idea of the disk method, then move on to the washer method. So first of all, let's consider the function f of x equals x squared over 2 on 0 to 1. And let's see, what is that going to look like? See, x squared on 0 to 1, it's over 2, so it's going to go to a half. It's going to look like this. Now I want to rotate this thing about the x-axis. So I want to take this thing and spin it around the x-axis. When I do, I'll get something like this. This will be down here at negative 1/2. And what I do is I form this cone-looking thing that's actually a solid. Now I can slice this thing. Let's just say I take a spot on the x-axis right here and take a look at a slice. If I now look down this x-axis, if I look in that direction on the x-axis at just this slice, what I see is a circle. I see a disk. And what's happening is as I move this slice up and down the x-axis, the radius of this circle is going to be very small here, and it's going to be bigger here. So the size of this disk is constantly changing. So it'll be very small up to big. It's changing as we move along the x-axis. And the radius of this disk is actually going to be equal to this function, which was x squared over 2. So the area of a disk of any circle is pi r squared. So in this example, the radius, like I just said, is changing as x changes, and is equal to x squared over 2. So I can say then that the area of any disk, when I talk about any disk, as I move along the x-axis on this particular, or inside of this particular solid, can be represented as pi r squared, but that's pi times x squared over 2 squared, because this is the radius, r. And that's obviously equal to pi times x to the 4th over 4. Now, if I sum up all those disks, if I sum them all up, those infinite number of disks, that's the same as integration. So the volume is going to be equal to pi, I'm going to pull this 4 out, pi over 4 times the integral. In this case, along the x-axis, I'm going from the origin out to 1. I kind of stomped on my 1. There was a 1 right there. So I'm going from 0 to 1 of r squared. Well, right here is part of r squared. In this particular case, I'm going to end up with x to the 4th left over, because x to the 4th over 4 was r squared dx. Well, this would just simply be pi over 4 times x to the 5th over 5 evaluated from 0 to 1, which is pi over 20. So if I revolve this thing around the x-axis, the solid that I get will have a volume that's equal to pi over 20. And you notice I do not have any units on here. It's pi over 20 cubic whatever. If this happens to be 1 yard, it's cubic yards. If this is an inch, it's cubic inches.